Few people would imagine that an old motorcycle valve like this could become part of a DIY welding tool. Instead of throwing it away, today I'm going to reuse this valve along with a few simple materials to build a mini welding tool. First, I'll start by disassembling the valve to collect the parts needed for the build. I use tweezers to remove the valve core from inside. Once removed, the valve becomes hollow, allowing me to reuse the metal body as the heating handle for the welding tool. Next, I use a binder clip as the support piece to hold the heating section. I attach the valve to the clip and tighten the nut to secure both parts firmly together. In the next step, I connect the electrical wire to the heating handle. First, I use pliers to strip the insulation from the wire and expose the copper core inside. Then, I twist the copper wire around the binder clip. This creates a more stable electrical contact and also helps keep the wire firmly attached during operation. I use pliers to tighten the connection one more time to make it more secure and prevent it from loosening during use. Next, I move on to designing the handle for the welding tool. Here, I use a plastic tube as the handle because it is lightweight, easy to grip, and most importantly, non-conductive, making it safer to use. However, the binder clip is much smaller than the inside diameter of the plastic tube. So, I fold a tissue and wrap it around the clip to increase its size and help the heating section fit tightly inside the handle. Then, I feed the heating wire through the plastic tube first. After that, I insert the heating section into the end of the tube and adjust its position carefully. Finally, I apply super glue around the contact area between the heating section and the handle. Once the glue dries, it helps secure the heating section firmly and reduces movement during operation. Next, I reuse an old battery to make the soldering tip. First, I use pliers to remove the outer metal casing. I use a utility knife to remove the plastic outer layer of the battery. I choose the battery core as the soldering tip because it can conduct electricity and withstand heat relatively well. Additionally, it is easy to shape, allowing me to sharpen it for better precision during welding. Then, I grip the inner core with needle nose pliers and gently twist to pull it out. I clean the core using a tissue. This will serve as the soldering tip. After that, I attach the core to a drill to shape it. I turn on the drill and press the tip against sandpaper to sharpen it. Sharpening the tip improves contact precision, making the welding process easier and more effective. Next, I attach the soldering tip to the heating section to complete the overall welding tool. In the next step, I prepare the electrical connection system for the welding tool. I use an electrical clip along with 2 metal washers to create the power connection points for the system. I also use this blue wire as the ground wire for the welding setup. First, I strip the insulation from the wire to expose the copper core inside. Then, I connect the wire to the back of the electrical clip. I use pliers to clamp the metal tightly around the wire, making the connection more secure and preventing it from coming loose during use. For the other end of the wire, I connect it to the metal washer. This part acts as an electrical contact point, helping the current flow more steadily while the welding tool is operating. For the remaining wire of the welding tool, I also attach it to the second metal washer to complete the electrical connection system. I carefully adjust the contact points to ensure a firm and stable connection during operation. To power the welding system, I use a 21V battery pack. When I press the power indicator button, all 4 battery lights turn on, showing that the battery is fully charged and ready to use. During the welding process, I place a piece of wood underneath as a support pad to provide insulation and protect the working surface. Next, I connect the washer from the welding tool wire to the positive terminal slot of the battery. Then, I attach the washer from the ground wire to the negative terminal, completing the electrical circuit for the welding system. When I touch the welding tip to the ground clamp, sparks immediately appear. The tip quickly turns orange due to the rising temperature, showing that the system is working properly. First, I test the tool by welding 2 razor blades together. I place the blades overlapping each other and attach the ground clamp to one side to complete the electrical circuit. Then, I gently tap the welding tip on a contact point. At the point of contact, the metal heats up rapidly and the surface begins to melt and bond together. I repeat the process several times with short contact durations to avoid overheating and warping the blades. After a few passes, the 2 blades become firmly connected. Although the weld is small, it is quite strong, proving that the DIY welding system works effectively. For the next test, I repair the handle of a metal strainer. First, I use the heat from the welding tip to warm up the contact area between the handle and the metal mesh. As the temperature rises, the metal begins to glow slightly red, making the surface easier to bond. Then, I apply a small amount of solder to the heated area. The solder melts quickly and spreads around the joint, creating a stronger and more durable connection. Once cooled, the handle becomes firmly attached and no longer feels loose. I gently tap the metal strainer against the table to test the strength of the weld. The handle remains firmly attached, with no shaking or signs of coming loose. For the final test, I engrave text onto a wooden board covered with aluminum foil. I attach the ground clamp to one side of the board to create a stable electrical path. Then, I move the welding tip across the foil surface. When the tip touches the foil, the heat lightly burns the surface and creates visible engraved lines. I slowly guide the tip to form the word "like." During the process, small sparks appear at the contact point, while the engraved lines remain smooth and easy to control. If you found this video interesting and helpful, don't forget to leave a like and subscribe to support the channel. Thank you for watching, and I'll see you in the next DIY videos.